Students, today we will start our third chapter, that is force and pressure. Okay, so we all know that what is force, right? Force is a quantity by application of which a moving body can be stopped, or by application of which we can change the direction of a moving body, is not it? So we can say that force is an external agent which changes or tends to change the state of rest or uniform motion of a body, or changes its direction or shape, is not it? Actually, in very simple terms, force is defined as push or pull, right? So we know that two types of forces are there. One is contact forces and another one is non-contact forces. Okay, but in this chapter we will read about the moment of force. Okay, so when you apply force on an object, it moves in the direction of the force applied, right? Suppose we are applying force to this pencil in the forward direction, okay, then it will move in the forward direction. But when you apply force on an object which is not free to move, that means it is fixed about an axis of rotation, that is, it is pivoted at a point. Okay, example, door. So when you are closing or opening the door, or when you are applying force on the door, it will produce a turning effect. Okay, that is, it will rotate or turn about its hinges. Okay, this turning effect is called the moment of force. Okay, the moment of force is actually the turning effect produced by the force. So we can take another example. Okay, so if we take a spanner, then we know that spanner is used to loosen or tighten a nut, is not it? So this nut about which the spanner rotates is the fixed point, is not it? And it is also called pivoted point or axis of rotation. Okay, so what is pivot or axis of rotation? So pivoted point or axis of rotation is the point about which the body or object is fixed and capable of rotating. Okay, so when we apply force on the spanner, it will produce a turning effect. Okay, so we can define the turning effect as, that means the moment of force, like the turning effect of a single force about a fixed point, that means pivot, is called the moment. Okay, in other words, a moment is the turning effect of a force around a fixed point called pivot. Now it is clear, is not it? So for example, this could be a door opening around a fixed hinge, or a spanner turning around a fixed nut, is not it? So the moment of force depends on two factors. Okay, number one is the force applied, and number two is the perpendicular distance from the fixed point, that means pivot, to the line of action of the force. Okay, so more the force applied, more the turning effect. Okay, if a child apply force to open a door, he will not be able to open the door, is not it? But a man can easily open the door, right? And the second point is distance between the, that means the moment of force depends upon distance between the fixed point or axis of the body and the point where the force is applied, is not it? Actually, the moment of force, that means the moment, is the product of the force and the distance between the that means the perpendicular distance from the line of action of the force to the pivoted point. Okay, so M equals to F into. A spanner used to tighten or loosen a nut has a long handle to produce a large moment of force by a small force applied normally at the end of its handle. Okay, so we know that if the perpendicular distance from the line of action of the force to the pivot is larger, then the moment of force produced is also large, is not it? Because we know that moment of force depends upon force and distance, and it is the product of force and distance. So we can say that larger the perpendicular distance from the line of action of the force to the pivot, then the moment of force produced is also very large. Okay, so that a spanner used to tighten or loosen a nut has a long handle. Okay, there are two kinds of moments. One is clockwise and another one is anti-clockwise moment. Okay, so now we will discuss about some examples of turning effect. Okay, So the first one is, in a hand folder cutting machine, the handle is fixed at the edge of the wheel so that there is maximum distance between the force and the turning point. Okay, this generates maximum moment of force. Why? Because we know that as the distance between the that means we know that the perpendicular distance from the line of action of force to the pivoted point, if it is large, then the moment of force produced is also very large, is not it? Then less effort is needed, is not it? Okay. And the second one is, hand flour grinders are commonly used in villages for grinding flours. Okay, the upper circular stone of the grinder is provided with a wooden handle near its edge. Why? In such a case, the distance between the handle and the turning point will be maximum, is not it? And then it less effort is needed to turn the upper wheel. Okay. Okay. So now we will discuss about couple. What is couple? So always remember that a single force alone does not cause rotation of a pivoted body. Okay. Actually, rotation is always produced by a pair of forces. Okay. Actually, the pair of forces formed by the external force applied and the force of reaction is called a couple. Okay. Or we can say that two equal and opposite parallel forces not acting along the same line form a couple. Okay. And always remember that a couple is always needed to produce a rotation. Okay. So the turning moment caused by a couple of force is called a torque. Okay. So what is the definition of torque? A pair of equal sized turning forces acting in different directions is called a couple, and the turning moment caused by a couple is called a torque. Okay. Now we will discuss about unit of moment of force. So we know that the moment of force is the product of force and the distance. So the unit of moment will be equals to the unit of force into unit of distance. We know that the SI unit of force is Newton and the SI unit of distance is meter. So the SI unit of moment of force will be Newton into meter, that means Newton meter. Okay. So now we will discuss about numerical problems on moment of force. So the first one is, the hinge of a door is at a distance of 40 centimeter from the point of application of force. That means the hinge means the pivoted point actually. If a force of 20 Newton is applied, what is the magnitude of moment of force? So we know that force equals to the moment of force equals to force into distance. So the force is here, the force applied is 20 Newton and the distance is 40 centimeter. So 20 into 40, that means 40 centimeter means 0.4 meter. So 20 into 0.4 means 8.0 Newton meter. And the second one is, what is the perpendicular distance between the force and the turning point if a force of 25 Newton produces a moment of force of 12.5 Newton meter. So here moment of force is 12.5 Newton meter and force is 25 Newton. We know that moment of force equals to force and into perpendicular distance. Here force is 25 Newton and we need to calculate the perpendicular distance, and the moment of force is 12.5 Newton meter. So moment of force divided by force will be the perpendicular distance. So 12.5 by 25, that means 0.5 meter will be the perpendicular distance.